Okay, today we're going to talk about a single number, just one. But this one number can literally mean the difference between a garden that explodes with life and one that's a total bust. We're not talking about sunlight or water, but something much more invisible, soil pH. So yeah, let's dig in.
So you might be asking, why all the fuss? Why is getting this one number so important for my plants? Well, the answer is hiding right there, just beneath our feet, in the invisible chemistry that's running the whole show. You can think of soil pH as this secret signal, like a hidden code in the ground. It's basically an instruction manual that tells all the nutrients whether they can feed your plants or if they have to stay locked away. Our job is to learn how to read that signal.
And there's a reason why the pros call it the master variable. It's not just some passive measurement. No, this single value actively controls a whole bunch of other stuff, from which nutrients are available to how active the good microbes are in the soil. It really is the key that unlocks everything else.
So what are we really measuring here? It's just a scale, right? A scale of how acidic or alkaline your soil is. A pH of 7.0? That's perfectly neutral, like Switzerland. Anything below that is on the acidic side, and anything above it is alkaline. It's a simple scale, but man, the effects are huge.
And here's why. See, most plants have a sweet spot they absolutely love, usually somewhere between a pH of 6.0 and 7.5. Why there? Because in that perfect little window, all the essential nutrients, we're talking nitrogen, phosphorus, potassium, are basically served up on a silver platter for the plant's roots. It's their all-you-can-eat buffet.
Now here's what happens when you're outside that prime real estate. If your soil gets too acidic, crucial goodies like calcium and phosphorus are basically put in lockdown. And to make things worse, nasty stuff like aluminum can be released, which is straight up poison for plants. And on the flip side, if the soil is too alkaline, other key nutrients like zinc become impossible to get. So either way you slice it, your plants are either starving or being poisoned. Not good.
Okay, so we've established the stakes are pretty high. We absolutely have to get an accurate pH reading. But, and this is a big but, the very tool we use for this, our pH meter, can totally lie to us if we're not careful. It can be a little deceptive.
This quote from Metronome really hits the nail on the head. Without calibrating, you can get results that seem right. They're consistent, they're specific, they are precise. But they're also completely wrong. They're inaccurate. And honestly, that's the most dangerous combination of all.
Let me give you an analogy. Imagine a clock on the wall that is always, without fail, exactly 10 minutes fast. Every time you look at it, it gives you a precise time, but that time is always wrong. An uncalibrated pH meter is exactly like that fast clock. It spits out a number, sure, but it's not the truth.
So, to fix this, we have to perform what I like to call the accuracy ritual. And it's not a chore, really. Think of it as the essential process that forces our instrument to snap out of it and tell us the truth about our soil. This ritual, of course, is calibration.
So how do we actually do this? How do we perform this ritual and make our meter an honest broker of information? Well, it's really just a process of teaching it, of showing it what known values are supposed to look like.
The whole process is very methodical but simple. First, you give the electrode a good rinse. Then you place it in a special liquid, a buffer solution, that has a known pH, let's say exactly 7.0. You let the meter take a reading and you tell it, hey, this is what 7.0 looks like. Then you rinse it again, and you repeat the process with a second buffer, maybe one that's pH 4.0. You're giving the meter two solid anchor points, creating a reliable map for it to measure everything else against.
Now listen up, because the little details here are everything. You have to use fresh buffer solutions, your calibration is only as trustworthy as they are, always rinse between measurements so you don't cross-contaminate, and here's a big one. Whatever you do, do not wipe the delicate electrode with a cloth. It can create static electricity and totally throw off your readings. Seriously, one tiny misstep here can ruin the whole thing.
So once the ritual is done, the meter actually gives you a report card on itself. You have to think of this as checking your work. Understanding this report tells you if your calibration actually worked, and more importantly, if your gear is even in good shape.
The first number you're going to look for is the offset. This is your meter's home base, its starting point. It tells you how well it reads perfect neutrality. In a perfect world, zero electrical signal should equal a pH of exactly 7.0. If that number's off, your meter's whole starting point is crooked.
The second number is the slope. Okay, so if the offset is the starting line, the slope tells you if the rest of the ruler is marked correctly. It's measuring how well the electrode responds as the pH gets more acidic or more alkaline.
A good slope means your meter is just as reliable measuring something super acidic as it is something super alkaline. It's consistent.
And here they are. These are the numbers you're shooting for. You want a slope that's between 95 and 103% and an offset that's somewhere between a pH of 6.8 and 7.2. If your numbers land in this zone, then congratulations. Your meter is properly calibrated and you can actually trust the numbers it gives you from now on.
All right, we've gotten pretty deep into the technical weeds here, so let's pull back and bring this all back to where we started, the garden. How does this boring old number actually translate into a beautiful, thriving patch of green?
This, right here, is the big payoff for all that work. A trustworthy number tells you exactly what to do. Your soil's too acidic? You know to add some lime to raise the pH. Too alkaline? You add sulfur to lower it. Suddenly, you're not just guessing anymore. You're making a precise, informed decision that will actually help your plants instead of accidentally hurting them.
And that's really the whole point of this. That's the core idea. Good, accurate measurement takes you from making a wild guess and hoping for the best to making a confident decision. It gives you the power to see the invisible world beneath your feet and actually work with it.
You know, this whole process, calibrating a tool so you can understand a hidden reality, it applies to so much more than just gardening, doesn't it? It kind of makes you wonder what other invisible data is out there shaping our world, just waiting for the right tool and the right calibration for us to finally understand it.